geometry students, to the review sheet up video, page 693, 1 through 71. Let's go ahead and get started. First of all, on numbers 1 through 5, the directions say to simply find or solve the square root. Okay, so we're going to use our calculators and we're going to very quickly solve these. Okay, so with your calculators, type in the square root of 58 and you will get 7.61577. We're going to round to one decimal place, so 7.6. Number 2, we're going to solve this square root. So with your calculator, type in the square root of 7 and you will get 2.6 if you round correctly. Number 3, type into your calculator the square root of 41 and you will get 6.4 if you round correctly. Number 4, if you type into your calculator the square root of 134, if you round correctly, you will get out 11.6. Number 5, same thing. Type into your calculator the square root of 106, and if you round correctly, you will get out 10.3. Now, I want to go back to the page, the first number. Remember, we were solving these, okay? When you're asked to solve a square root, you simply type it into your calculator, unless you have it memorized, like we know the square root of 36 just equals 6, because 6 times 6 equals 36. Now, if you don't know this, then go ahead and type it into your calculator and you'll get out 6, okay? So use your calculator when the directions say to solve. Very simple. Numbers 6 through 10, the directions say to multiply and then simplify. Notice it does not say multiply and then solve. That's not what it says. It says multiply and then simplify if possible, okay? Now if we're going to simplify radicals, we need a list of perfect squares. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and there's more. We'll just stop there for now, okay? So this is called a list of perfect squares, okay? And we're going to use this to help we're going to use these numbers here to help us simplify square roots. Now obviously you need to have these numbers memorized, but they're so easy. I mean, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 5, etc., etc. So they're really easy to remember. Now, let's go ahead and multiply. You have an outside number of 1, outside number of 1. 1 times 1 is 1. Inside number times inside number. 11 times 5 is 55. Okay? So there we go. You do not need that 1 if you don't want it. Now, are we finished? Or can you simplify? Well, let's see. Do any of these numbers go into 55 evenly? No. So we are finished. There's nothing you can do with that. You cannot simplify it. Number 7. Okay, here we go. Let's multiply. Well, there's no numbers on the outside. Multiply inside number times inside number, and you get 49. Now, guys, this is a perfect square, so there's no need to use these numbers over here to simplify. Think about it. You know the answer to this. 7 times 7 equals 49, correct? So, the square root of 49 is simply 7. That is the answer. Pretty simple, okay? If it's a perfect square, if it's a number you know the square root of, you do not have to simplify it. You just simply write your answer. Okay, number 8. Square root of 12 times square root of 6. Inside number times inside number. Square root of 72. Okay? Now, Let's see if any of these numbers go into 72 evenly. And let's see. 4 goes into 72 evenly. But to be honest, students, you really want the biggest number. I would always start with 100 and work my way down. This number does not go into 72 evenly. This one doesn't. No. But 36 goes into 72 evenly. So instead of putting 37, I would put 36 times 2. See how I did that? Isn't that easy? Pick a number on this list that goes into your radicand evenly, okay? And then write this number out as a factor of two numbers. Now, do you know the square root of 2? No, you do not, but you do know the square root of 36. So cross off 36 and put a 6 on the outside. So now you're left over with 6 square root of 2. How do you know that you're finished? Because none of these numbers here will go into 2 evenly. So your answer is 6 square root of 2. Alright, number 9. Now, be careful on this one. 3 square root of 2 squared. Look, if I had 5 squared, that simply means write the 5. How many times? Twice. And then multiply. That's what 5 squared means. So, if I have 3 square root of 2 squared, that simply means write 3 square root of 2 twice. And then multiply. Outside number times outside number would be 9. Inside number times inside number would be 4. Now hold it. We don't need to simplify the square root. 4 is a perfect square. It's right here. 2 times 2 equals 4. So the square root of 4 is 2. So 9 square root of 4 really means 9 times the square root of 4. So we really have 9 times. Now, some students get confused, and for the square root of 4 they put the square root of 2, and that's incorrect. The square root of 4 is not the square root of 2. How do I know that? Because the square root of 2 times the square root of 2 is not 4. 2 times 2 is 4. So the square root of 4 is 2. So 9 times 2, which is 18. So the answer is 18. Alright, number 10. Even though you can't see it, your outside number here is 1. So 1 times 2 is 2. Inside number times inside number would be 144. 48 times 3. Well, guys, 144 is a perfect square. I mean, I know it's not in your list right here, but that's because we stopped at 10 times 10, okay? 12 times 12 is 144. So, 2 times the square root of 144 is really 2 times 12. The square root of 144 is 12, and 2 times 12 is 24. So the answer is 24. Alright, moving on to numbers 11 through 15. We're going to simply simplify. That's all the instructions say is simplify. So, do any of these numbers over here go into 99 evenly? We'll start at the bottom and work your way to the smallest number. It goes all the way down to 9. So 9 goes into 99 evenly. So instead of putting 99, I'm going to put 9 times 11. The square root of 9 is 3. Cross off the 9, put a 3 on the outside, and your final answer is 3 square root of 11. Alright, number 12. Start at the bottom and work your way up. Do any of these numbers go into 28? Only 4 does. That's it. 4. So, 28 is the same thing as 4 times 7. Okay? So, with that in mind, I do not know the square root of 7, but I do know the square root of 4. So cross off the 4. The square root of 4 is 2. Put a 2 on the outside. So your answer is 2 square root of 7. These are really not that difficult, students. Moving on to number 13, 150. Students, if you start at the bottom and work your way up, not know the square root of 6, but I do know the square root of 25. Cross it off and put a 5 on the outside. So 5 square root of 6. You know you're finished because none of these numbers will go into 6 evenly. Alright, number 14, 32. We'll start at the bottom and work your way up. 16. 16 goes into 32 evenly. 16 times 2. Now, by the way, if you ever want to use a smaller number, feel free to do that, like 4 also goes into 32. You can use a smaller number. It just takes more time. For example, if I have a fraction like 16 over 32, and I reduce it by 2, that leaves me with 8 over 16. But then I got to reduce it by 2 again, and that would give me 4 over 8. Then I got to reduce it by 2 again, that would give me 2 over 4. Then reduce it by 2 again, and it finally gives me 1/2, okay? So you're welcome to use a smaller number, like 4. But watch what happens. You're going to have to do it more than once. Okay, 4 times 8 is 32. Cross off the 4, the square root of 4 is 2. So now you're left with 2 square root of 8. But now 4 goes into 8 again, so now you have 2. And then 4 times 2 is 8. Then cross off the 4, square root of 4 is 2, put a 2 on the outside. When you do that, you multiply these numbers. So you're left with 4 square root of 2, okay? And you're welcome to do it that way, but it's a lot faster if you use the bigger number. If we would have used 16, we would have had 16 times 2 is 32. Cross off the 16, put a 4 on the outside, and you get 4 square root of 2. And it's a lot faster, alright? Okay, number 15. 98. Let's see here. What number would go into 98 evenly? 49 would. So instead of putting 98, I'm going to write 49 times 2. I do not know the square root of 2, but I do know the square root of 49 is 7. Put a 7 on the outside. 7 square root of 2 is your final answer because none of these numbers go into 2 evenly. So 7 square root of 2. Alright, numbers 16 through 19. We have 45, 45, 90 triangles, okay? Now let's write some things out here. In 45, 45, 90 triangle, the leg equals the leg, alright? The hypotenuse equals, this is all stuff that I taught you, okay? The hypotenuse equals the leg times the square root of 2. And the leg equals the hypotenuse divided by square root of 2. Now this only works in 45, 45, 90 triangles, okay? So here we go. This is a leg. This is a leg. This is the hypotenuse, and we're solving for x, okay? Now, the legs are congruent, so if I knew the length of this leg, it would be the same as this leg, but I don't know the length of this leg. However, I do know the length of the hypotenuse. Well, look what you can do right here. When you know the length of the hypotenuse, you can divide it by what? Square root of 2, and that gives you the leg. So, I'm going to take my hypotenuse, 2 square root of 2, right here, and divide that by square root of 2. Let me say it again, students. Anytime you're dealing with a 45, 45, 90 triangle, if you know the hypotenuse, simply divide it by the square root of 2, and you'll get the leg. If you know the leg, simply multiply it by the square root of 2, and you'll get the hypotenuse, okay? So, 2 square root of 2 over square root of 2. Well, look, these just cancel out. Square root of 2 cancels with square root of 2, and you're left with 2 over 1, or just 2. So the leg is 2. X equals 2. Alright, number 17. Once again, we have a 45, 45, 90 triangle now. They want us to, in this problem, to solve for x and y. Now, x obviously is 45 degrees. Let's do that first. How do I know that? Well, because I know this is 45. I know this is 90. I know all three angles have to add up to 180. So 45 plus 90 is 135. If you subtract that from 180, degrees. So I know this is 45. Okay? Now, next, they want us to solve for y. And y, of course, is the hypotenuse. Here's your 90 degrees. Go straight across. Y is your hypotenuse. Now look right here. How do you find the hypotenuse? You take your leg and you multiply it by square root of 2. What is your leg? 5. So take your 5 and multiply it by what? Square root of 2. It's that easy, guys. So 5 square root of 2 equals your hypotenuse. Or in other words, it equals your y. Okay? Moving on to number 18. Now, here they want us to solve for x. Notice they called both of these legs here x. That's because they're the same. Remember, students, in a 45, 45, 90 triangle, your leg equals your leg. That will always be true in a 45, 45, 90 triangle. Okay? So with that in mind, they've given us the hypotenuse. Now, when you know the hypotenuse, how do you find the leg? You take the hypotenuse and you divide it by the square root of 2. So, pretty simple. Here's my 90 degrees. Here's my hypotenuse. Take your hypotenuse and divide it by the square root of 2. These will cancel, leaving you with 8 over 1, or just 8. So if one leg is 8, then the other leg must also be 8. So x equals 8. Alright? Okay, moving on to number 19. Now, on a test or a quiz, you better listen to me, students. If I would not have to tell you this is a 45, 45, 90 triangle, the directions tell you, excuse me for yawning, if you'll look in your book at numbers 16 through 19, the directions say you are given a 45, 45, 90 triangle, but you can see that with your own eyes. You know this is 90. So if you take 180 minus 90, you're left with 90. That means these two angles here have to add up to 90. But look, they're congruent. That means you take 90 and divide it by 2, and you'll get 45 and 45. So we do have a 45, 45, 90 triangle, okay? And they want us to solve for x and y. Now, look carefully. Have they given us a leg or a hypotenuse? Well, your hypotenuse is right here. Here's your 90 degrees. Go straight across. This is your hypotenuse. So they have not given us the hypotenuse. They have given us a leg. So first of all, a leg always equals the other leg in a 45, 45, 90 triangle. So if this is square root of 2, we know the other leg is also what? Square root of 2. That's pretty simple, okay? Now, for y though, whenever you're given a leg, how do you find the hypotenuse? Well, you take the leg times square root of 2. So what is my leg? Square root of 2. You take that leg times square root of 2. Square root of 2 times square root of 2 is square root of 4. Multiply your inside numbers times your inside numbers, okay? Well, the square root of 4 is a perfect square. We know the square root of 4, it's just 2. So the answer to y is 2. Alright, moving on to numbers 21 through 24. Find the value of each variable. Now notice all of these 4 triangles, numbers 21 through 24, are what we call 30, 60, 90 triangles, okay? Let me write down the rules I taught you guys, and I've got to think them through for a second. It's going to be very confusing. Let's see. The hypotenuse is always twice as big as the shorter leg. The shorter leg is always half the hypotenuse, so take the hypotenuse and divide it by 2. The longer leg always equals the shorter leg times, I've got to think this through for a second, let's see, square root of 3. Okay, so there's what you've been taught, and that should be very beneficial. You need to know that for your quiz coming up, or your test coming up over this chapter 10, okay? You need to know this, this right here. You must know these things, students, or you're not going to do well on your test. Alright, here we go. Now, let's label all of your sides. Start with your 30 degrees. Well, this is 30, this is 90, this has to be 60. Go to your 30, that's your smallest angle straight across. This is your shorter leg over here. Got it? So this is 90, go straight across, this is your hypotenuse. So the only thing left is your longer leg. So why is your longer leg? Let's go over that again. You go to your smallest angle, which will be 30. Go straight across. That side will be your shorter leg, always. Then go to your 90-degree angle. Go straight across. That side will be your hypotenuse, always. And the other side is your longer leg. So here we go. They've given us the hypotenuse. So let's think this through. If I know the hypotenuse, it's really easy. Let me put it to you this way. Anytime you know the shorter leg, it's really easy to find the hypotenuse. And anytime you have the hypotenuse, it's really easy to find the shorter leg. Okay, students, I'm back. Sorry about that. My cell phone was ringing there. But anyways, guys, listen, whenever you're given the hypotenuse, it's so easy to find the shorter leg. And whenever you know the shorter leg, it's so easy to find the hypotenuse. It's almost like in a circle. The radius is always half as big as the diameter. If you know the radius is 2, the diameter is 4. If the diameter is 4, then the radius is 2. Same thing. If you know the hypotenuse, divide it in half and you have the shorter leg. If you know the shorter leg, multiply it by 2 and you have the hypotenuse. So we know the hypotenuse is 14. Cut it in half and you know the shorter leg. So the shorter leg is 7. X equals 7. X equals 7. Now, in order to find the longer leg, what do you always do right here? Always take the shorter leg and multiply it by the square root of 3. Always. So your shorter leg is 7. So we're going to take 7 times the square root of 3 to get the longer leg. 7 times the square root of 3 is 7 square root of 3. So that would be your y. Alright, number 22. Alright, this is 30 degrees here. Now, always go to your 30, go straight across. This is your shorter leg. Go to your 90 degrees, go straight across. This is your hypotenuse. So this is your longer leg right here. Okay? Now, how do you find the shorter leg? Well, look, guys, think about it. I should have written this down for you. Look, if the longer leg is always the shorter leg times the square root of 3, then we know the shorter leg is always going to be the longer leg. The opposite of this, so it'd be divided by the square root of 3. Think about it. If the hypotenuse is 2 times the shorter leg, then the shorter leg is the hypotenuse divided by 2. If the longer leg is the shorter leg divided by the square root of 3, then the shorter leg is the longer leg divided by the square root of 3. So the longer leg is 8. We're trying to find the shorter leg, correct? So we put 8 right here for the longer leg. So the shorter leg is 8 divided by square root of 3. 8 divided by square root of 3. Alright, number 23. Now, 30, 90, this is 60. Okay, go to your 30 first, go straight across. This is your shorter leg. Go to your 90 degrees, go straight across. This is your hypotenuse. So this is your longer leg. Now, first of all, if you know the shorter leg, it's always easy to find the hypotenuse. Multiply this by 2. So we know for sure the hypotenuse is going to be 10, because you simply take the shorter leg and multiply it by 2. 5 times 2 is 10, okay? Now, how do you find the longer leg? Well, you always take the shorter leg and multiply it by the square root of 3. What's the shorter leg? 5. So we take 5 times the square root of 3. 5 times the square root of 3. So x equals 5 square root of 3. That's your longer leg. Alright, number 24. 30, 60, 90 is your special triangle. Remember, these 60, 90 triangles. Okay, go straight across from the 30. This is your shorter leg. This is 90, go straight across. This is your hypotenuse. This is 60, go straight across. This is your longer leg. Right, here we go. Now, I'm giving you the longer leg. Well, if you know the longer leg, remember it's really easy to find the shorter leg. You take the longer leg and divide it by the square root of 3. It's that simple. So I know what the longer leg is at square root of 3. We're going to take the longer leg, we're going to divide it by the square root of 3, and that'll give us the shorter leg. So longer leg, 6 square root of 3 divided by square root of 3. Those cancel, leaving you a 6. So the shorter leg equals 6. Alright? So your shorter leg is 6. Now, we know the hypotenuse is always twice as big as the shorter leg. So if the shorter leg is 6, double that, or 6 times 2 would give you 12. Then the hypotenuse has to be 12. Alright? Moving on to numbers 25 through 27. Find tangent of R and S. So don't forget these formulas right here. You'll need these for the test, okay? So, SOHCAHTOA. So first of all, in the directions they want us to find the tangent of R. So circle R, go straight across. This is your opposite. 90 degrees, go straight across. This is your hypotenuse. And this is your adjacent side. Please always do that for students. Listen to me. Circle the angle you're dealing with, then label all 3 sides, okay? Alright, so tangent of R, opposite over adjacent, okay? So opposite is 8. Adjacent is 15. So the tangent of R equals 8/15, okay? Now, next they want us to find the tangent of S. So circle S. Go straight across. This is your opposite side. This stays your hypotenuse. And this is your adjacent side. Alright. Now, the tangent of S would be opposite over adjacent, 15 over 8. Okay? Alright, moving on to number 26. Alright, now, once again, let's start off with the tangent of R. Circle R, go straight across. This is your opposite. Here's 90, so this is your hypotenuse. So the last side is your adjacent, okay? So the tangent of R equals opposite over adjacent, 53 over 56, okay? Now, next, let's find the tangent of S. Tangent of S. So you circle the angle you're dealing with, go straight across. This is your opposite. This is your hypotenuse. This is your adjacent. So the tangent of S would be opposite over adjacent. Okay? Moving on to number 27. There's the answers. Number 27. Okay, here we go. Let's start off with trying to find the tangent of R. If I asked you to find the tangent of R, you would circle R, go straight across. This is your opposite side. Here's your 90, go straight across. This is your hypotenuse side. And the last side is your adjacent side. So tangent of R would equal opposite over adjacent, 2/3. Alright? Now, next we're going going to circle S, and we're going to find the tangent of S. Circle S, go straight across, this is your opposite. Here's 90, go straight across, this is your hypotenuse. And this here would be your adjacent side. Okay? So, tangent is opposite over adjacent. 3 over 2. Alright? And there are the answers. Alright? Okay, now, numbers 28 through 37 are just calculator problems. We're going to use a calculator to find the tangent of given angles. So, I'm going to go through this very fast. Make sure your calculator's in degrees. If you type in tangent of 15, you'll get this, if you round correctly. If you type in the tangent of 72, you'll get this. Notice on these numbers, please listen to me, students. Notice on numbers 28 through 37, you are given an angle. Got it? You are given an angle. Later on, we're going to do problems where you're missing the angle like this. Something like that, okay? And you have to find the angle. When it's like that, you use a different button on your calculator. Right now, we're just using the tangent. And we're taking the tangent of a given angle, so we just type in tangent of 72 degrees. Type in tangent of 60, you should get this. Type in the tangent of 9, you should get this. Type in the tangent of 32, you should get this. Type in the tangent of 33, and you should get this. Tangent of 31, type it in correctly, and you will get this right here. Tangent of 35, with your calculator you would type in tangent, and then 76, and then hit enter. Make sure your calculator's in degrees. You should get that. Tangent of 58 would be this. And the tangent of 49 would be this. Now, students, earlier, way back here, you were finding tangent when you were given a right triangle, the three sides of a right triangle. In these problems, you're finding the tangent when they give you the actual angle, 49 degrees, for example. Okay? So know how to do both of those types of problems. Alright, numbers 38 through 40, find the value of x to the nearest tenth. Now, students, if you will listen to me carefully, I will help you learn how to do this quickly. Whenever you're given a right triangle, the best way to find a missing side is to use Pythagorean's theorem. It is easy. You make substitutions, use your calculator, and you're home free. Here's the problem though. Whenever you use Pythagorean's theorem, you must know at least how many sides. 2. If you don't know 2 sides, you cannot use this. And we don't know 2 sides. But remember, anytime that you do know 2 sides, use Pythagorean's theorem, okay? Alright, back over here. Well, they've given us an angle, so circle it. Now go straight across. This is your opposite side. Here's 90. Go straight across. This is your hypotenuse. This side here is your adjacent. So, I have some questions for you. What angle do they give us? This angle. What side do we know? Opposite. What side are we looking for? Adjacent. So, we really don't need the hypotenuse. We're looking for this side, and we know this side. So, what trig function has adjacent and opposite? Isn't it tangent? Yeah, tangent is opposite over adjacent. Got it? So here we go. We can set up a really nice equation. Tangent of, what angle are we dealing with? We might put angle D, that's true, but we have an actual number we can put in there. Tangent of 65 degrees equals opposite over adjacent. There it is. Now, here's your unknown. First of all, remember something right off the bat, students. Tangent of 65 should not be confusing. Please listen to me. Tangent of 65 all understand that tangent, and hold on, my mimeopad just quit working, so hold on 1 second here. There we go. Alright, tangent of 65 is nothing more than a number. So type in tangent of 65 and you'll get this. 2.1445 equals 8 over x. Now, whatever your denominator is, multiply both sides by that number or by that letter. The bottom of the fraction is x, so I'm going to multiply both sides by x. When I multiply this side by x, let me say that again. Mr. Earhart, how'd you know to multiply by x? Guys, whatever the bottom of your fraction is, multiply both sides by that thing, whether it be a variable or a number. So the bottom of my fraction is x. Multiply both sides by x. So on the left side I have 2.1445x. If I multiply this side by x, 8 over x times x over 1, your x's cancel, leaving you with 8. Now look, you know what to do, guys. You have 2.1445x. Divide both sides by what? 2.1445. These will cancel, and x equals, let's see, 8 divided by 2.1445 gives you 3.73, or in other words, 3.7. Okay, 3.7. So there you go. Let's try some more of these, okay? Alright, number 39. Now, here's the angle they gave us, so circle it. Go straight across, we'll call this opposite. This is 90. Go straight across, we'll call this hypotenuse. So your last side here is adjacent. Now, we're going to use this angle here. We know this side here, so we're going to use that side. And this side is x. So we're going to use this side. Now, which trig function has opposite and adjacent? Right here, tangent does. Tangent equals opposite over adjacent. So we're going to use tangent because tangent is the function that has opposite and adjacent. So here we go. Tangent of what angle? 38 degrees equals opposite over adjacent. Now, first of all, remember, tangent of 38 is just a number. Alright, so here we go, students. I'm going to grab my calculator real quick. I'm going to type in tangent of 38, and you'll get this, 0.7813 equals x over 17. Now, what is your denominator? 17. So you're going to multiply both sides by 17. So if you take 0.7813 times 17, you're going to get 13.2816. If you multiply this side by 17 over 1, 17's cancel, leaving you with x. So the answer is 13.28, 13.3. Okay? Alright, moving on to number 40. Same thing. Now let's be really careful here. I know that I have here a right triangle. Okay? Right here. There's a right triangle. Okay? So forget the rest of this thing. There's a right triangle, okay? Now, circle this angle. Go straight across. This is your opposite side. Here's your 90. Go straight across. This is your hypotenuse. And this is your adjacent down here. So, this is the angle I'm using. This is one side that I know adjacent. This is the one side I'm looking for opposite. So which trig function has adjacent and opposite? Tangent. So here we go again. Tangent of what angle? Well, what angle did I circle? 50 degrees equals opposite over adjacent. Now tangent of 50 is a number, and the tangent of 50 is 1.1918. Now your denominator is 10, so multiply both sides by 10. If you multiply this side by 10, you'll get 11.918. If you multiply this side by 10, you'll get x. So x equals 11.918, or in other words, 11.9. And there's your answer right here, 11.9. Okay. Alright, moving on to numbers 41 through 43. Okay, students, on 41 through 43, it says find the sine of r and the cosine of r. And so here we go. This is an 8, by the way. Alright, let's start out by finding the sine of r. So we're going to circle r, go straight across. This is your opposite. Here's 90, go straight across. This is your hypotenuse. This is your adjacent side, okay? So sine of r would be opposite over hypotenuse, okay? Opposite over hypotenuse. So opposite would be 8. Hypotenuse would be 17. There we go. Now let's find the cosine of r. Well, we're still dealing with angle r, so there's no need to circle r and do all of this again. Cosine of r is adjacent over hypotenuse, okay? So adjacent is 15, and hypotenuse is 17. So the cosine of r is 15/17. Okay? Alright, moving on to number 42. Let's find the sine of r, okay? The sine of r equals opposite over hypotenuse. Here's r, go straight across. Opposite, here's 90, go straight across. Hypotenuse, so your other side here is your adjacent side. Now sine is opposite over hypotenuse, or 33 over 65. Cosine of r, and we've already circled r, is adjacent over hypotenuse. So 56 over 65. Really pretty simple. Alright, number 43. We're dealing with angle r, so circle r, go straight across. This is your opposite. Here's 90, go straight across. This is your hypotenuse. And this side here would be your adjacent. Alright, so let's start off by finding the sine of angle r. Now the sine of r would be opposite over hypotenuse. Opposite over hypotenuse, 2 over square root of 13. Alright, 2 over square root of 13. The cosine of r would be adjacent over hypotenuse, so 3 over square root of 13. Okay, pretty simple actually. Alright, number 44. Now numbers 44 through 53, I'm going to go pretty fast because you're just typing things into your calculators, okay? So here we go. The sine of 33, if you type it in correctly, will be this. Cosine of 78 would be this. Cosine of 8 degrees would be this. Sine of 40 would be this. Sine of 57 would be this. Sine of 43 would be this. Sine of 80 would be this. Cosine of 20 would be this. Cosine of 89 would be this. And sine of 12 degrees would be this right here. Okay? Really not too difficult, students. Really pretty simple. Alright? Okay, moving on to numbers 54 through 56. Find the lengths of x and y. Round to the nearest tenth. I'm not really too worried about where you round, but let's go ahead and solve these, okay? Now, students, listen to me. We're missing two sides of a triangle. Now, I wish that we had a 30, 60, 90 triangle, but we don't. I wish we had a 45, 45, 90 triangle, but we don't. going to be able to use our shortcuts that we use when we have a 30, 60, 90 triangle, or when we have a 45, 45, 90 triangle. We're just not going to be able to do that, okay? So, with that in mind, we're going to have to use sine or cosine. So circle the angle. By the way, at the level of geometry or trigonometry we're at now, you never want to circle your right angle. Just never do that, okay? Now, in advanced trigonometry, we get into sine, cosine, and tangent of 90 degrees, okay? But we don't do that right now in geometry, okay? So, never circle your 90. Okay, circle this angle here. Go straight across. We'll call this what? Opposite. Here's 90. Go straight across. We'll call this hypotenuse. So this side here is your what? Adjacent. Now, if you'll listen to me carefully, students, I will really help you. Okay? Now look. You've got to choose, first of all, whether you want to solve for x or y first. I don't care. But whatever you do, do not solve for x and y at the same time. That's impossible to do. You're going to have two different unknowns in one equation. So don't use tangent, because tangent has opposite and tangent has adjacent. If you use tangent, you're going to have tangent of what angle? 42 equals x over y. That's not going to work. You have two unknowns. That's crazy. Okay? So, what you want to use is either sine or cosine. Now, do you want to solve for x or y first? We're going to go for x. So if you're solving for x first, that's what? Opposite. And we have to use the side that we know, which is hypotenuse. So we're dealing with opposite and hypotenuse. What would that be? That would be sine. Sine has opposite and hypotenuse, okay? So I'm going to write sine of what angle? 42 degrees equals opposite over hypotenuse. There it is. Set up perfectly. Opposite is x, hypotenuse is 15. Now, don't forget sine of 42 is an actual number. So if you type that into your calculator, you'll get 0.6691 equals x over 15. Now, what is your denominator? 15. Multiply both sides by 15. If you do that to the left side, you'll get 10.037. If you multiply this side by 15, you'll get x. So there we go. The answer to x is 10.0, or just 10. Okay? Now, students, we have to find our last side. So now we're dealing with adjacent and hypotenuse. See it? Adjacent and hypotenuse. Mr. Earhart, why not use this side over here? I guess you could, because we know it's 10, but you did round that, so it's not 10 exactly. So I would not use this side. We know 15 is exactly 15. So my advice to you is to use adjacent and hypotenuse, and that would be cosine. So cosine of what angle? 42 degrees equals adjacent over hypotenuse. Okay? Now, go ahead and take the cosine of 42 degrees, and you will get 0.7431. Now, multiply both sides by your denominator, 15. And if you do that correctly, you're going to get 11.147. If you multiply this side by 15, you'll get y. So if you round correctly, you'll get 11.1 for y. 11.1. Okay, not too bad. All right, number 55. Okay, they give us this angle here, so we're going to circle it. Go straight across. This is my opposite. Here's your 90. Go straight across. This is your hypotenuse. And this will be your adjacent let's look for x first. So we're dealing with opposite. Here's the one side we know, hypotenuse. So we're dealing with opposite and hypotenuse. That's going to be sine. Sine is the function that has opposite and hypotenuse. So we have sine of 26 degrees equals opposite over hypotenuse. There it is. Opposite over hypotenuse. Well, the sine of 26 is an actual number. Okay? And hold on one second. The sine of 26 is 0.4384. Now, your denominator is 18. So we're going to multiply both sides by 18. 0.4384 times 18 is going to give you 7.891. If you multiply this side by 18, you're left with x. So the answer over here, if you round correctly, will be 7.9. 7.9. Now, next let's solve for y. So we're dealing with y and the hypotenuse. Adjacent and hypotenuse. Which trig function deals with adjacent and hypotenuse? Cosine does. So the cosine of 26 degrees equals adjacent over hypotenuse. Alright? Now the cosine of 26 is 0.8988 if you round correctly. 0.8988. Now what is your denominator? 18. So we're going to multiply both sides by 18. If you multiply 0.8988 times 18, you're going to get this right here. 16.178. If you multiply this side by 18, you're left with y. So if you round this correctly, it'll be 16.2. 16.2. Alright? Okay, moving on to number 56. Number 56. Now this one will be a little different because notice here, they give us the hypotenuse. No, I'm sorry, it'll be identical to the last two. So it'll be just like the last two problems, which is good practice. Nothing wrong with that. Okay, here we go. Let's circle the angle they've given to us. Go straight across. This is your opposite. Here's your right angle. Go straight across. This is your hypotenuse. So this is your adjacent side right here. Okay, we're going to solve for x first. So x is your adjacent side. And what's the side that I know? My hypotenuse side. I know is 7. So which trig function has adjacent and hypotenuse? Cosine does. So we're going to solve for x first by using cosine. Cosine of 68 degrees equals adjacent over hypotenuse. Now cosine of 68 is an actual number, and the cosine of 68 is 0.3746. Now multiply both sides by 7, because your denominator is 7. So if I multiply 0.3746 times 7, I'm going to be left with 2.622. If I multiply this side by 7, I'm left with x. So if you round correctly, you should get 2.6 for x. Alright? Now, moving on to solving for y. Y is my opposite side. 7 is my hypotenuse. So which function has opposite and hypotenuse? Sine does. So I have the sine of 68 degrees equals opposite over hypotenuse. Well, sine of 68 is 0.9272 if you round correctly. And now the denominator is 7, so we're going to multiply both sides by 7. 0.9272 times 7 will give you 6.490. If you multiply this side by 7, you'll be left with y. Okay? So really y, if you round correctly, y should be 6.5. 6.5. Now students, please listen to me. There is no reason to be confused on numbers 57 through 68. No reason whatsoever. Alright? Do you see the difference between this problem here and this problem over here? In this problem here, you were given the angle and you were looking what it equaled. In other words, you were looking for this number right here. Now it's the opposite. They're giving you this number here and you're missing the angle. So you're trying to find the angle. Here I gave you the angle and you took the tangent of that angle using a calculator. Here you're missing the angle. I'm saying the tangent of some angle gives you this. So these are done differently because you're looking for an angle. So remember this, students, anytime you're looking for an angle, that's when you use the second tangent or the inverse tangent button on your calculator. So somewhere on your calculator should be a button that says tangent to the -1 power, which is really pronounced inverse tangent or tangent inverse. Okay, so you want to type into your calculator so this comes up on your screen, and then type in 0.8734, hit enter, and you'll get this right here, 41.1 degrees. Okay. All right, number 58. Notice on 58 that we're missing an angle. So we're going to hit second sine or inverse sine, and this should pop up, and then type in 0.8045. If you type that in correctly, you will get this right here, 53.6 degrees. Make sure your calculator is in degree mode, okay? All right, moving on to number 59. We're missing an angle, so we're going to hit second cosine, and then type in 0.2933. If you do that correctly, you will get this right here, 72.9 degrees. Number 60, notice we're missing an angle, so we're going to hit inverse tangent, and then type in 1.6. And if you do that correctly, hit enter, you will get 58 degrees. Okay, students, moving on to number 61. Okay, notice we're looking for an angle. We're missing the angle, so we hit cosine inverse, and then type this number into our calculator. And you should get this right here, 27 degrees. Number 62. Notice we're missing an angle, so we type in inverse sine, and then type in this number here. Hit enter, and you should get this right here. Alright, number 63. Notice we're missing an angle, so that's when we type in inverse tangent, and then type in this number here. Hit enter, and you should get this right here. Alright, number 64. Notice we're missing an angle. We're missing an angle, so we hit second cosine. Then we type in this number here, and you should get out this number right here, 47.2 degrees. Alright, 65. Notice we're missing an angle. Okay, so we're going to type in inverse sine, then type in this number here, then hit enter, and you should get this right here. Number 66. Notice we're missing an angle, so we hit second tangent, then type this number in, hit enter, and we should get this number right here, 29.8 degrees. Moving on to number 67. Notice we're missing an angle right here, so we're going to hit inverse sine, then type this number in, hit enter, and you should get this right here. Alright, number 68. Notice we're missing an angle right here, so hit second cosine, or inverse cosine, and then type in this number here, hit enter, and you should get this number right here. Alright, moving on to 69, 70, and 71 now. In 69, 70, and 71, you're solving right triangles completely. That means you're trying to find every missing part, okay? Well, look, if you're given two angles, find the third angle quickly. If you're given two sides, find the third side quickly by using Pythagorean's theorem. So notice, on this right triangle, we know two sides, do we not? So let's use Pythagorean's theorem to find the fourth side. Leg squared plus leg squared equals hypotenuse squared. Well, rid of both sides, and you will get 15. So there we go. Now the only thing left for us to find are two angles. This angle here and this angle here. Now students, would you please listen to me carefully? It does not matter which angle you solve for first. It does not matter. I'm going to circle A because I feel like it, no other reason. So circle A, go straight across, this is your opposite. Go your right angle straight across, this is your hypotenuse. And this is your leftover side, adjacent. Now students, I'm going to find this missing angle right here by using sine, cosine, or tangent. It does not matter which of these two sides that you use. Because I feel like it, I'm going to circle these two sides right here. Do you understand me? You do not have to circle those two sides. You could circle these two sides, or you could circle these two sides. It doesn't matter which two sides you circle, as long as you match up the two sides that you circle with the proper trig function. For example, I said I'm going to circle these two sides, correct? What two sides did I circle? Adjacent and opposite. So which trig function has opposite and adjacent? Tangent. So when I go to set my thing up, I'm going to write tangent. Okay, what angle did I circle? A equals opposite over adjacent. Okay? Now, we just learned back here, whenever you're missing the angle, you hit second cosine or second sine or second tangent. So am I not missing an angle? Yes, I am. So hit inverse tangent or second tangent, and this will pop up. And then type in 12 divided by 9. Then hit enter. Now, if you do that correctly, you're going to get 53.1 degrees. If you round correctly, 53.1. So now, right here in my triangle, I'm going to write 53.1. Now you're probably thinking, Mr. Earhart, to find this last angle here, I've got to use sine, cosine, tangent. No, you don't. What is this angle here? 53.1. What is this angle here? 90. If you add these two together, you get 143.1. Well, you know all three angles, 1, 2, 3, have to add up to 180. So just subtract that from 180, and you will get 36.9. 36.9. So there we go. There's your answers, and they are exactly correct, okay? Let's try a couple more of these. Number 70. Alright, now, first of all, students, I want you to notice that you know two sides. If you know two sides, find the third side by using Pythagorean's theorem very quickly, okay? So leg squared plus leg squared equals hypotenuse squared. So now I have 25 plus leg squared equals 100. Subtract 25 from both sides. Leg squared equals 75. Now take the square root of both sides, and your leg equals the square root of 75, which, if you type that in correctly, you will get 8.7. So this leg right here is 8.7. Now, students, you're missing this angle and this angle. It does not matter which angle you try to solve for first. I'm going to try to solve this one first. So circle that, go straight across, this is your opposite. Here's your 90, go straight across, this is your hypotenuse. And this side here is your adjacent. If you circled this angle and set up your sides correctly, you'll get the exact right answer, okay, no problem. Now, I'm going to use personally these two sides here because they're whole numbers, and I really don't want to use a decimal, that's the only reason. So I'm going to find angle F by using these two sides right here. Now, what two sides did I circle? Adjacent and hypotenuse. So which trig function uses adjacent and hypotenuse? Well, I think that's going to be cosine, is it not? Here's adjacent. Here's hypotenuse. It's cosine. So I'm going to write cosine of what angle? What angle am I looking for? F equals adjacent over hypotenuse. Now, am I looking for a missing angle? Yes, I am. So I'm going to hit inverse cosine or second cosine, and then type in 5 divided by 10. Hit enter, and you should get, for angle F, 60 degrees. F equals 60 degrees. If you're not getting that, you're making a mistake somewhere with your calculator. So if this is 60 and this is 90, add these two together, subtract from 180, this has to be 30. Okay, 30 degrees. So there we go. We solved all of the missing parts of this right triangle. And last but not least, number 71. So here we go, students. First of all, notice that we know two sides. So let's quickly find our third missing side. We have a leg squared plus a leg squared equals a hypotenuse squared. So we have 16 equals leg squared, or plus leg squared, equals 81. Alright, subtract 16 from both sides, and we should get 65. Take the square root of both sides, and you will get 8.1. So your leg equals 8.1. So this is 8.1. Now, students, we know all three sides. Now we're missing two angles, this one and this one. Once again, it does not matter which angle that you circle. It does not matter. I'm going to circle C because I feel like it, no big deal. So go straight across. This is my opposite side. Here's 90, go straight across. This is my hypotenuse. This is my adjacent. So I'm looking for angle C. I'm going to use these two sides here because they're both whole numbers, okay? So which trig function has adjacent and hypotenuse? Cosine does, okay? So I'm going to put cosine of C equals adjacent over hypotenuse, okay? Now notice I'm missing an angle. And whenever you're missing an angle, that's when you use second cosine or inverse cosine. So inverse cosine of 4/9. Hit enter, and you will get 63.6 for C. So C is 63.6. This is 90, okay? If you add these two together, you'll get 153.6. Subtract that from 180, and you will get 26.4 degrees. 26.4 degrees. Okay, so that's it, students. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.